All right, we're going to be crime investigators today. Both Mary and Tom are missing, and we must figure out who may have taken them. Who could it be? Could it be Mr. Carroll over there? I don't know who took them, but somebody took them. So as police, we will look at what the two had in common to see if we can figure out where this kidnapper is. What do they share? So let's look at Mary and Tom and see maybe some connection. Well, here's everything about Mary. Here's everything about Tom. I see they both vacation at Myrtle Beach. So maybe there's some connection there. Mary's working at Walmart where Tom's over at Moe's working. Anywhere else? Do they shop? No, one shops at Kroger, the other there. Oh, wait, they both work out at River Valley Fitness. So maybe the person kidnapped them there. They both work in Wildwood. Okay. The other one's still vacation Chicago, vacation New York City. So this is what they share. So these are the three things that they share, that they both have. These are the three spots we'd be looking to figure out, hey, there's some connection between Tom and Mary at these spots. Not at the other things, but at these spots. Now, this is the same idea we're going to use when we try to factor out common factors or greatest common factors of two expressions. So if we look at this, we want to factor 4n squared plus 6n. So we want to see what they both share, what they both have, what they have in common. Well, if we break everything down all the way, the 4 down to prime factorization, it's a 2 times 2 times n. And the 6 is a 2 times 3 times n. What do they seem to share completely? Well, they both share a 2. And they both share a what? N. So what we would do is we would factor those out. We would factor out a 2n and say, hey, they both have that. Now, what do they have left inside? So, well, with my first piece, it has a 2 and an n. So it has a 2 and an n. My piece here just has a 3. So actually, this factored is 2n times the quantity 2n plus 3. Notice that if we took the 2n and distributed it through here, it would give us back 4n squared. And then if we distribute the 2n through to the 3, it's going to give us back the 6n. This is simply what we call factoring out, is what most of us would say. We have factored out a 2n. If we break it down like this each time, we'll see it. And we might need that at the beginning. As you get older, or have more experience, I guess I should say, you'll look at this and say 4 and 6 and say, hey, they both have a common factor of 2. N squared, n, they both have an n. So we'll see what factors out a little bit more quickly. All right, let's look at the next one. Okay, what does it have? This guy has an A, B, 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 C, C. This guy has an A, A, B, 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 C. So we want to say, hey, what do they both have? They both have an A. He has 3 B's. He has 3 B's, B cubed. He has a C. He has a C. So what do they share? They have an A, B cubed, and a C. And what was left behind? Well, what was left behind in this guy's a C. What's left behind in this one is AB. Now, again, this times the C, if we distribute it through, would give us back the first piece. And if we took the AB cubed C, distribute through the AB, we would get back this piece. And again, a lot of us would look at this as we get more experience and say, hey, A squared, and A can come out. B cubed, B fourth, most can come out as B cubed. C squared, C, most can come out as a C. And that is, you'll notice what we factored out. And then they figure out what was left behind. All right, we look at this. If we break it down, if we break 8 down, notice if you look at 8 and 4, you say, hey, what's the biggest, greatest common factor? Well, it's going to be 4. 4 can be factored out of both. But if we break it down into its prime factorization, we're going to get that. And again, maybe we need to do this. Maybe we don't. It's up to you. Depends on how much you see. So when I'm looking at this, I'm like, hey, he has a 2. He has a 2. He has another 2, another 2. He has an A, has an A, has a B, has a B. So we factor out a 2 times A times B. And then what was left behind? Well, a 2bb, which is 2b squared plus, now notice everybody got pulled away. There's still a number there because we still have that place. A 1 was left behind. You can't forget the 1. If you do, you get the wrong answer. Because in the end, we're going to take this, which is 2, so really this is just 4ab times 2b squared would give us back this. And then we need that 4ab times something right here, which is the 1, which gives us back that 4ab. If you get rid of it, then the 4ab just completely disappeared. So you've got to make sure that if everybody factors out, you are left behind with the number 1 there, and you've got to make sure you put it. One more problem here. Notice this time there's 3 pieces. We have 4a plus 6b plus 10b. Now notice nothing comes out. They don't share anything except for all of them are even. So a 2 could factor out. So I'm just going to do that. I'm going to factor out a 2. Well, what would be left behind? 2 times what would give you back 4a? Well, 2a. 2 times what would give us back 6b? A 3b. And then 2 times what would give you a 10b? That's going to be a 5b. Now, a lot of you might think, oh, why didn't you pull a b out? Because this guy didn't have a b to give. This first piece, there wasn't a b. And they all have to have that. They all have to have it in common. That's how we call it what we do of factoring out.